everyone, it's Shakya and welcome back to my YouTube channel. In this video, I'll be talking about binary tree traversals, in-order, pre-order and post-order. So what is a binary tree? A binary tree is a data structure in which each node has a maximum of two children, called the left child and the right child. So a tree traversal is visiting every node of a binary tree exactly once in a specific order. And depending on when we visit the root node, we get different traversals. So first, let's talk about the depth-first approach. So the depth-first approach for a binary tree explores as deep as possible down one branch, usually the left, before backtracking and trying other paths and visiting each node down first. And this is implemented using the three main traversals in order, pre-order, and post-order using recursions or stacks to manage the nodes. In the in-order traversal for a binary tree, it processes the nodes in the order left subtree, root, and right subtree. So this means that first it will recursively traverse all the nodes in the left subtree, and then it will process the current root, and then finally it would recursively traverse all the nodes in the right child subtree. So now let's take a look at a simple tree to see how the in-order traversal works. So I have given a simple algorithm here as well. So as you can see, we first visit the left node and then we visit the root node and then we visit the right nodes. So here we can see that A is our root node. So from A we go left, then we get B, and then we go left again, we have C. So C has no child node, so both left and right is null. So C is the leftmost node. So we have C. And then we go to the root node, that is B. So we go left, then root, and then right. So now since we are done with the left subtree, we go to the root of that, which is A. And now we go right to E. So E has no left child, so that is null. So from left we go to the root. So then we get E. And then we go right, so we get F. So the order is C, B, D, A, E, F. So in the pre-order traversal, it would visit each node in the order root, left and right. So this means it would first process the current node and then it would recursively traverse all the nodes in the left subtree and then it would recursively traverse all the nodes in the right subtree. So now let's take a look at an example tree to see how the pre-order traversal works. So here too I have given a simple algorithm. So as you can see, first we visit the root node and then we go left and then we go right. And if a node is null, then it would return. So the root node of this is A. So first we have A and then we go left. So we have B and B is the root here as well to C and D. So we have B and then we go left again and we have C and C has no other left or right child nodes. So we have C and then root left and then we go right. So we have D.
and then we go to the right side, and first we have E, since E is the root of F, and then E has no left, so we go to right, so we have F. So the order will be A, B, C, D, E, F.
So in the post-order traversal, it will visit each nodes in the order left subtree, right subtree, and root. So this means that it would process all the child nodes before visiting the parent node. So first it would recursively traverse all the nodes in the left subtree, then it would recursively traverse all the nodes in the right subtree, and then finally it would process the root node.
So now let's take a look at an example to see how the post-order traversal works. So here too I have given a simple algorithm. So we go to the left node, then we go right, and then we visit the root node. And if the node is null, it would return. So here the parent node is A again. So we go left, then we go to B, and then we go left again, we go to C, and there is no other nodes from there. So the leftmost is C. And then from C we go right, so we have D. So left, right, and then we go to the root, which is B. And we are done with this left subtree, so then we go to the right, so we have E, and E has no left, so we go to right, so we have F, and then we go to the root of that, which is E, and then to the root of both of these, it's A. So the order will be C, D, B, F, E, A.
So now let's take a look at a few applications of these three traversal types. So the Inorder Traversal is used in binary search trees for sorting. So in a binary search tree, the left child is smaller than the root and the right child is larger than the root. So the Inorder Traversal can be applied to get the values in an ascending order. So this can be seen in search engines, file indexing systems, and also in databases.
So the in-order traversal can also be used in an expression tree. So an expression tree is a type of binary tree that represents an expression that can be a mathematical, a logical, or a conditional expression. So I have a simple tree here. So let's see how this works. So as you can remember, in the in-order traversal, we first go left, then we go to the root, and then we go right. So here the leftmost node is 3. So 3 is left, and then we go to the root, so that will be plus, and then we go right, so that will be 5. So 3 plus 5, and then we go to the root again, so we have this, and then we go right, so we have 2. So finally we get the expression 3 plus 5 into 2. So this is also an application of the in-order traversal.
The preorder traversal is also widely used for storage and transmitting trees. So by saving the nodes in the preorder along with the null markers, we can reconstruct the exact same tree later. So this is used in network transmissions, distributed systems, and file storage. So the post-order traversal is used to delete a tree. So in order to save the deleted tree, we first delete the left subchild, then the right subchild, and then finally delete the root. So this post-order traversal ensures that there are no memory leaks, so therefore it is used in memory management. And that's it for today. If you guys have any questions, feel free to drop them down in the comments below. Thanks for watching, and I'll see you in my next video.